Hello, I'm Ian McCluskey, and you've made it to video number 5 in our 7-part guide to designing DC-coupled systems. Here we are going to match up our charge controller selection with our solar PV array size and determine the best possible configuration for them. If you recall from the last video, we already had to specify a charge controller, or at least a placeholder charge controller, for the maximum modules in series calculations to size the PV array. If you get to this step and decide to change the charge controller, just make sure to revisit the max modules in series calculation to make sure it doesn't change the result. The whole point here is to make sure that they are both compatible with each other. Run the first formula here with each of the values you found for minimum and maximum modules in series, and any values in between. Next, we find the maximum array, STC, power rating of the charge controller you selected at battery voltage you selected. For example, 12 volts, 24 volts, 48 volts on the datasheet. Run the second formula for each power per series string value you just found. You might have gotten anywhere between 1 and 6 reasonable values for the minimum and maximum modules in series in the last section. Make sure to run both of these formulas for each value. Keep these numbers handy for the next formula, as the answers all play into each other. Seriously, this really is the final step on the more challenging DC side of the system design. Your answer should be less than 1, or you selected too large a controller. It is important to note that a multi-mode system may have an oversized PV array for net metering purposes. So if the customer's target size will take precedence over the smaller minimum array size. In an off-grid system, it is possible to slightly oversize the PV array as well, but to protect the system's integrity, I recommend going no more than maybe 20% over the minimum solar PV array based on our earlier load analysis. Make sure that none of the manufacturer warranties on the equipment you've selected have a maximum size as well that would prevent any oversizing at all. This is because a charge controller can only handle so many series strings in parallel before there is too much total current flowing through the sensitive electronics. As an example, if the charge controller you selected will accept 3 strings of 4 panels, but the formula here gives you 6 strings of 4, the decision to use 2 charge controllers is obvious. However, if the formula here states 4 strings of 4 panels, splitting those up onto 2 oversized controllers may be less cost-effective than simply selecting a larger charge controller and revisiting the string sizing calculations for a more efficient configuration. Now, if you've been following along with an example system as suggested, the DC configuration picture should be pretty clear at this point. Another matrix table with preset formulas could come in handy for this last step of optimization on this and your future designs. Maybe you have already decided on your series and parallel string numbers, but if there is even a bit of doubt as to the most effective design, this last step will clear it up. Maybe the customer wants to see 2 or 3 viable options so they feel like they are part of the decision-making process. Maybe you already have charge controllers on hand and have to make the system fit on them. There are many good reasons for this last step. If you are not sure how much energy each result will produce, plug the values into PV watts for a production forecast by hour, month, and year. Well, the AC system configuration is up next. We're almost there.